Hello students, welcome back to my channel Engineers Academy. Let's solve this problem 228. In this problem it is said that determine the magnitude of this force F so that the resultant Fr of these three forces is as small as possible, right? And it is said that what is the minimum magnitude of Fr, right? So we are given these three forces. The magnitude of this F is not known, but this F is making 30-degree angles with the horizontal, right? So we have to find the resultant magnitude and we have to find the minimum magnitude of the resultant, right? So we have to minimize the resultant of these three forces, right? So this problem looks simple, but it involves some concept that we have to learn, right? So first what we will do to solve this problem is that we will find the resultant of this 8 kilonewton force and this 6 kilonewton force, right? So now as we can see that this 6 kilonewton force is acting in the positive x direction. If this is my positive x and this is my positive y direction, right? So we can draw that this 6 kilonewton force is acting in the positive x direction like this, right? So let's say that I write that this is 6 kilonewton force, right? And as we can see that this 8 kilonewton force is acting in the negative y direction, vertically downward, right? So by head to tail rule, what we need to do is that we need to draw this 8 kilonewton force on the head of this 6 kilonewton force, right? So let's say that this is that 8 kilonewton force which is acting vertically downward, right? So I will write that this is 8 kilonewton force, and the resultant of both of these will be from the tail of the first to the head of the last, right? So this is the resultant, right? So let's say that this is F dash. Let me write that the resultant of these two is F dash. So now as we can see that both of these are making 90-degree angle with each other, right? So this is a right angle triangle. So we can find the magnitude of the resultant of both of these by using the Pythagoras theorem, right? So then F dash will be equal to 6 square plus 8 square, and this will be under the square root. So then this is equal to 10 kilonewton, right? And similarly, if we want to find the angle of the resultant of both of these with the positive x-axis, right? If this is our positive x-axis, right? So let's say that this angle is theta. So we can find this theta by applying tan theta, since this is a right angle triangle, right? So we can write that tan theta will be equal to the perpendicular divided by base. So this is 8 divided by 6, right? So from this, theta equals to tan inverse 8 divided by 6. So theta comes out from this equals to, this is 53.13 degrees, right? So this means that this F dash is making 53.13 degrees with the positive x-axis, right? So this is 53.13 degrees, right? So now since we are required to minimize the resultant of these three forces, right? So now what we will do is that we will find the resultant of this F dash with this F force, right, which is unknown. We are given that F force which we need to determine the magnitude, that F force is making 30 degrees with the positive x-axis, right? So if I draw a x-axis is here, right? So this force is making 30 degrees with the positive x-axis, so it is also making 30 degrees with the negative x-axis, right? So we can write that this angle is also 30 degrees, right? So this means that the magnitude of this force can vary, right, in order to maximize or minimize the magnitude of the final resultant, right? But its direction is fixed, right? So now what we will do is that we will add F dash and this force F, right? This is that force F to find the final resultant, right? So in order to do that, what we need to do is that we need to place this force F on the head of that F dash, right? Again, we will apply the head to tail rule, right? So what I will do is that I will place this force F with the same orientation. We can't change the orientation since the angle is given, that is 30 degree. So if I place it here, right, so then the resultant of both of these will be from the tail of F dash to the head of this F force, right? Now let's say if I draw the line of action of this F force, let's say that this is our F force which we need to find its magnitude, right? So if the magnitude of this force can increase or decrease along this line, right? Since we are required to minimize this Fr, this green one is the final resultant of all these three forces, right? So if we want to maximize the resultant magnitude, so then what we can do is that we can move this F vector along this, the line of action of this F, right? So as we can see that as I move the head of this Fr towards left, so its magnitude is increasing, right? And as I move this Fr vector towards the right, so its magnitude is decreasing, right? So since we want to minimize, so then we have to move this Fr vector towards right, and we have to identify the location where the Fr magnitude will decrease, right? So along the line of action of this F, we will have one particular point where the magnitude of this Fr will be minimum, right? And at that particular point, this Fr will be making 90 degrees with this F force, right? So if let's say that this is that point, let's say that this is point P. If let's say at this point P the resultant magnitude is minimum, right? So then at this particular point this Fr and this F will be making 90 degree with each other, right? And if we move again this resultant vector, the head of this vector on the line of action of this F force, so towards the right of this point P, what will happen is that the length of this Fr will start increasing again, right? So as we can see, so this is the concept behind this, right? So this means that this Fr and this F is making angle 90 degrees, right? Now there is one another method we can say that where the Fr will be minimum, right? So let's say there is one another concept that I need to tell you people. So if we remove this angle, let's say that we do not know that what's the angle between Fr and P, the Fr and F vector, right? So let's say that this is my F vector, and let's say that this angle is unknown, let's say that this angle is alpha, right? And we know that this F force is making 30 degrees, so this angle is 30, right? This angle is 53.13, so then this angle is also 53.13. So this whole angle, let's say that this whole angle is, let's say, beta, right? So beta is equal to 53.13 plus 30 degrees, so this is 83.13 degrees, right? So this beta is known. The angle between the F dash and F force is known, which is fixed, right? So now if we apply the sines law to find the magnitude of this Fr, right? So we can write that Fr, by using sines law, Fr divided by the sine of this angle, right? So sine of beta, and beta is known, which is 83.13, and this is equal to F dash, and F dash magnitude is known, which is 10 kilonewton, right? So this is 10 divided by the sine of the opposite angle. So the opposite angle is alpha, right? So we can write that this is sine of alpha, right? So from this equation we can write that Fr equals to 10 sine of 83.13 divided by sine of alpha, right? Since we want to minimize the magnitude of this Fr, and from this equation we can see that the magnitude of Fr is 10 sine of 83.13 degrees divided by sine of alpha. So if we divide this term by large value, right, the larger value of sine of alpha, so this will minimize the Fr magnitude, right? So now as we know that the value of sine of alpha is in the range from 0 to 1, right? So as we know that the sine values are between -1 and 1, right? So as we can see that the minimum value here is 0 and the maximum value here is 1, right? So if we divide this Fr by the maximum value, this is the maximum value of sine of alpha, so this will minimize the Fr magnitude, right? So let's say that sine of alpha is 1, right? So if sine of alpha equals to 1, so from this we can say that alpha and equals to sine inverse 1 and sine inverse 1 is 90 degrees, right? So this means that if FR is making 90 degrees with F, so then the resultant magnitude will be minimum, right? So this is another conclusion from using the sines law, right? So in order to minimize the resultant, we need to have 90 degree angle, right, between the FR and F, right? So this means that this alpha angle is 90 degrees. So if alpha angle is 90 degrees, so then FR is equal to 10 sine 83.13 divided by sine of 90. So sine of 90 is 1. So then we will be only left with 10 sine of 83.13. And this is equal to FR from this is equal to 9.928 kilonewton. And similarly, we can find this F as well, right? So if we look into this triangle, right, this F dash, this F and FR, right, let's say that this point is O, let's say this point is B. So if we look into this OBP triangle, so this is a right angle triangle, and this F dash is the hypotenuse, right, and this F dash is making 83.13 degree angle with the F force, right? So this means that the F force will be the cos component of this F dash, right, since this is the base of this right angle triangle. So this will be F dash cos of the angle beta. This angle is beta, right? So beta is 83.13 degrees and F dash is 10. So this is 10 cos of 83.13 degrees. So 10 cos of 83.13 degrees is 1.196 kilonewton, right? So this is the magnitude of that force F, which is equal to 1.196, and this is the minimum resultant of these three forces, right, which is equal to 9.928 kilonewton. So I hope you people would have understood the concept behind this simple problem.